Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In the previous couple of video tutorials, we looked at performing supervised classification using LandSat datasets, both LandSat 5, 7, and 9. And we also use Sentinel images. And then we created a couple of classification images, and then we compared them in terms of overall accuracy. We've looked at comparing the LandSat versus the Sentinel. We looked at comparing LandSat 5 versus LandSat 9. We did a whole lot of comparisons to try to identify which series or which data set is best suited for the classification, and also between the methods, which method is the best for classification. And later on we also looked at looking at the seasons, winter versus summer. But we can also within Google Earth Engine perform unsupervised classification. Remember, the big difference between supervised and unsupervised is that with supervised, you as the classifier decide or identify your regions of interest or your training samples. So you decide on the locations where of the spectral signature. Okay, so you make that decisions. Whereas in unsupervised classification, that is determined by the algorithm itself. It's sometimes also called clustered classification. Okay, so unsupervised and clustered classification are the same thing, and then obviously you get supervised classification. So in this video tutorial, we're going to look at unsupervised or clustered classification. That is when the algorithm decides on the clustering of a number of spectral signatures. Okay, so you determine the number of classes, let's say 4 or 5, and then the algorithm then determine the range of all the spectral signatures, and then classify them together in 5 classes, and then presents that as an image classification. Okay, so let's have a look and see. Remember, we go to Google Earth, same story, code editor. In my case, I have created a script, and it's called Daytime Tutorial 2. So I go to my scripts, I scroll down, I find my script or my project name, I left click on it, and it will open in the script window. Okay, remember, you've got your console or your output window here, your map window there, and your scripts and your assets and all these things on your left hand side, etc. Okay, so let's start. I've got the 3 standard regions of interest. I've got my district region of interest. Remember the one that we initially used, but it's just too big, so I've made it smaller and I call the new one, which is just a particular municipality or specific region within that bigger region of interest. I've called that now the region of interest, which is this part displayed here. And then obviously I've got my original region of interest with the 200 random points, which is this points here, this file here. Okay, so I've got the thing. But you'll see I've created another geography here. Okay, geographical dimensions here or variable here. Okay, it's called regional cluster. Now, remember in the supervised, you use the classification here, the geometry inputs, and you use specifically the point marker, and you've created your different classes, and then within each class you identify your regions of interest or your training samples. Okay, so that you do with supervised. With unsupervised classification, you create one block, which as I said, in my case, I've called it regional cluster. And that's a training sample within your region of interest. So within this region of interest, I create a training sample, just one. Okay, and it's in the form of a polygon, meaning it's in the form of a polygon, not a point, but in terms of a polygon. And you'll see if I open it, you'll see there it sits. Okay, there it is. Okay, you'll see there. It's a bit small. I can't unfortunately zoom in because it's quite a lot of a map, so it's going to give me all sorts of warning signs that it's running out of memory, etc. So unfortunately, and you can create this training sample any place. Just don't make it too big because it's going to eat up a lot of your space and your size limits. Okay, so also don't make it too small because then it's not representative of your region of interest. So play around with the size to get the balance between having it too small and having it too big. Okay, but it's a polygon. Okay, in this area I've located here because it covers rivers, urban area, sand, soil, vegetation, etc. So it covers everything except the mountains, unfortunately. Okay, so yeah, so this is up to you, your discretion, where you're going to create it. Okay, so you go to your new layer. Okay, you go to draw a rectangle, draw a polygon, and you simply just, you see that the cursor have gone into this cross, and you draw your polygon there. Okay, it's drawn there. You'll see it sits there as a regional cluster 3. Okay, so it's going to update it now. I don't want it to be updated, so let's delete it. Okay, so in fact, let's redraw it again. I've drawn it there. So, okay, there it is, and we've called it. What did we call it again? It's included here somewhere. Regional cluster. Okay, so let's just copy it there and rename it, paste it, and done. Okay, and there it sits. Okay, there it is. Okay, so I just it's there, it's just unselected. Okay, so that's how you would create a polygon or your cluster your training cluster. Okay, I've called it regional cluster. It's your training cluster. It's a polygon that you can place anywhere. Okay, so except my original regions of interest, I've created one more. Remember, in unsupervised or clustered classification, please remember to include this training cluster. Okay, then I display, I've got my map, I've my clipping tool, I've got my various scaling parameters for LandSat 5 and 7, 8 and 9. I create the LandSat images, okay, for LandSat 5. We've already gone through the medium image for that period, LandSat 7, LandSat 8, LandSat 9. Remember the difference in the bands. You'll see there 5 and 7, obviously the same bands, 8 and 9, the same bands. And then obviously I add all of these median images for 5 to 7 to 9. That's medium images. I map them, I add them to my map. Okay, and then, okay, so I've got my 5 data sets, which is LandSat 5, 7, 9. So I'm going to perform a unsupervised or cluster classification using each of those 4 LandSat data sets. So I'm going to have unsupervised cluster classifications for LandSat 5, same for 7, 8, and 9. Okay, so I now have to create my color schemes for the classification. And in my case, I'm going to create 4 classes each. Remember, I don't specify what each class is. The algorithm will decide what class 1 is, what class 2 is, what class 3 is, or class 4 is, or category of features. Okay, you don't determine it, you just specify the number of classes, the number of feature categories you are interested in. In our case, we said 4. Okay, and obviously we're gonna give him this color. So class 1 will be gray, class 2 will be purple, class 3 will be class 0 will be gray, 1 will be purple, 3 will be green, 4 will be black, and 5 classes, 0 to 5 classes, and that is a color scheme. So we know that those areas generated with a gray color will be class 1, etc. We've also created a second color palette, which is also 0 to 4, but you'll see the color schemes are a little bit different, and that's because of the unsupervised classification method. Okay, they don't create the same classes for class 0. Okay, so one method could generate, let's say, green areas or vegetation in class 1, where another unsupervised method could generate those same vegetation and call it class 3, for example. So we just need to make sure that when we present the colors, they represent the same classes. Okay, so just bear that in mind. Okay, then we're going to generate our training sample. Okay, remember this is now where our regional cluster, that polygon within our region of interest, this is where it comes relevant, in that the algorithm will use that as the training sample and then extrapolate it to my region of interest. Okay, the scale and the maximum of pixels, and we're going to do it for each of the LandSats. Okay, so training LandSat 5 is using the LandSat image, okay, using that specific cluster as a training sample. And there is LandSat 7, exactly the same. So each LandSat data set have its own unique training algorithm or training classification. Okay. Then we're going to apply 3. Okay, so for each of the LandSat data sets, we're going to apply 3 unsupervised methods or cluster methods. Okay, we're going to use the KMeans, the XMeans, and the VQ. Okay, so go and have a read through it, go and research the ins and outs of each of those methods. But in general, the KMeans and the LVQ are very similar. However, the XMeans are a little bit different. You'll see in the specification, it's a little bit different. Okay, so we use 3 different unsupervised classification methods. Now, if you use the SCP doc in QGIS, obviously there's many more unsupervised or clustered methods, but for our sake in this particular exercise, we're going to only focus on 3, although there are more. Okay, so this is where you specify the classes. Okay, you specify the classes, 5 classes, and they are labeled from 0 to 4 or from 1 to 5. It's up to you how you're going to label it. Okay, so this labeling there relates to this number here. Okay, and I said KMeans, XMeans, and LVQ. That's the 3 methods that we are using. So in our first set of scripts, we initiate the cluster and we train it using those methods. Okay, and they relate to our LandSat 5 in this case. This is, remember, these variable names are up to your discretion. But as I said, it's called clustered. LandSat 5 KMeans, it is most descriptive of what I'm going to do. So it's going to train. What it's going to train? It's going to train the LS5. What is the LS5? That's that variable, which is that specific cluster. Okay, so we're going to train that specific cluster, that area there. We're going to train using KMeans, and we're going to generate 5 classes and so forth for the other 2 as well. Once we've done our training, we initiate the classification. Okay, so now we've done the training. Now we're going to use that training and we're going to extrapolate it to the region of interest as a whole. That's why you've got the image as a whole. And we're using the median image of that entire period. Okay, we're using the median period of the entire LandSat period as specified. Yeah, okay, so we use, remember, that's the medium image that we're going to create. Okay, medium of that specific image collection, and we give it that variable name. So LandSat 5 image is the median image of this entire collection. Okay, and you can again play around with your time periods, etc., etc. Okay, so first we're going to do the training of that cluster. Once we've done the training of the cluster, we then extrapolate it to my image as a whole. And then we actually just display it. Okay, remember that we use the cluster. Now you'll see the KMeans and the LVQ use the same color palette, which is cluster vis. That's one here. The gray, purple, green, black, and orange. Whereas the XMeans use the second palette, color palette, which basically has gray, green, black, and purple, which basically just swap the three middle colors around. Okay, you can see there. So purple becomes with the K-means and the LVQ. Purple is the second color or class 1, whereas for the X-means, purple becomes the fourth cluster. Fourth class, not the second class. So they swap around. So just bear that in mind. Then I add those classifications. Okay, so first I do the training, and once I've done the training for that region of interest or that cluster, this one here, I then extrapolate that training or classification to the region of interest, and then I display. And I do that for LandSat 7. Remember, there's LandSat 7. I train same cluster for LandSat 7. I do the training first, then I initiate the classification, and then I display the classification. And then for LandSat 8, exactly the same. There's my training sample, okay, which is that polygon that I specified using my layer options here, my geometry options here. I initiate my training for that specific cluster, and then I extrapolate it for the whole image. You'll see for the whole region of interest, and then display. And then it's the same for LandSat 9. Okay. So there they all are. So I have 4 images or 4 data sets, which is LandSat 5 median image, a LandSat 7 median image, a LandSat 8 median image, and a LandSat 9 image. So I've got 4 images, and I apply 3 classifications to each one. That means I will have 12 classification images. Okay, I'll have a K-means for each of the 4, an X-means for each of the 4, and an LVQ for each of the 4. And they have the same color patterns or same color palette. Okay, irrespective whether it's LandSat 5, 7, 9, 8 or 9. Okay, and there they all are. Okay, now they consume a huge amount of space, so unfortunately I can't zoom into it because I'm going to get a lot of red little warnings here that says I've exceeded my size, my allocated size. Okay, space. So unfortunately I can't zoom in again. It's because I've got 12 classifications, so that's quite a lot of computing power that I'm using. So displaying that is going to be a bit tricky. But anyway, so let's quickly unselect them all. Okay, unselect them. I'm not gonna. Okay, so there's my medium LandSat 5, 7, 8, and 9 images. I'm unselected to save space. Okay, so there's the LandSat 5 K-means. Okay, let's have a look at LandSat 7 K-means, and you can see quite a lot of differences. Let's have a look at LandSat 8 K-means. You can see again predominantly purple and greens. You can see that predominantly purple and greens. Okay, except LandSat 5. There's LandSat 7, LandSat 8 K-means, and LandSat 9 K-means. LandSat 9 is a lot of black and stuff. So yeah, you actually need to, okay, we're going to do the inspector now. Okay, so let's have a look at the X-means for LandSat 5, the X-means for LandSat 7, the X-means for LandSat 8, the X-means for LandSat 9. Yeah, so there's that. And then we do the third method, which is LVQ. There's LVQ for LandSat 5, LVQ for LandSat 7, LVQ for LandSat 8, and the LVQ for LandSat 9. Now, in all these cases, we don't know what those colors, the land classification of the colors. We don't know what green represents. We don't know what yellow, purple, black, etc., represent. So this is now where the manual part comes in. It's for us to go and put a land use classification to each color. Okay, so that's going to be, so this is what the algorithms generate for us, but obviously we now need to go and generate the color schemes. Okay, we need to say in the K-means, what is yellow? Or what is green? What does that mean? Is it water? Is it vegetation? Is it rock? Is it this? Is it that? Whatever the case might be. And if the classifications are not representative of the location itself, then obviously we need to maybe look at the classes. Increase the classes or decrease the classes. Okay. So there's LandSat 5. There's LandSat 5 K-means. So let's zoom in and see if this will work. I hope it doesn't give us any red warning signs to say we've exceeded our limit, because it is quite big. So while we're waiting for this LandSat 5 K-means to display, let's quickly go to our satellite. Now this is how you can identify the colors. Okay, so you'll see there's the colors, and immediately it looks like yellow is mountains. Okay, you can see there's the mountain. So yellow seems to be mountain. Green seems to be rivers. Okay, now obviously we can go and change the colors so that green becomes, so in the display for green, we can now say let's make it blue, for argument's sake. Well, if we think that green is not rivers. Let's just wait for it to load. But yeah, so that is the next step. So once we've done the unsupervised or clustered classifications, and we have our classification images, I said we now need to get understanding. What does yellow mean? What does green mean? What does purple mean? What does gray mean? You know, these colors here, what do they all mean? Okay, you can see black seems to be, this one here, seems to be rivers. You see there's water bodies. That's a river. That seems to be water. Green, if we zoom in, we're going to zoom in now. There's purple. We're going to zoom in and see what purple means. And then we've got gray, we've got purple, we've got green. And then we've got black. Yeah, there's our black, and then we've got orange. So orange seems to be the mountainous areas. That seems to be clear. Okay. Green most probably are vegetation. Green most probably are vegetation. Gray most probably are or is agriculture. And then the purple, we'll have to wait until, let's see, is it up and, okay, so there is, let's see what purple, what would purple be? Let's zoom in. Purple seems to be these green areas. Now, that seems to be what purple is. Purple is this heavy green area, which is agriculture. Okay, but it doesn't actually specify urban areas, so which could be, you can see it really takes a bit of time for these classifications to load, especially if you zoomed in. Okay, so there's purple. You'll see there's purple. If I unlock it, you'll see it's quite a bit of green there. Okay, which is irrigation vegetation. See, it's green. So green or purple, you'll see there, purple is very green areas. This grey, you'll see there, it is this type of vegetation. See, but here's green seems to be indicating a river. And there's a river that's indicating to be going to be blackish. Anyway. Okay, you'll see there. This green here. Remember what the algorithm does? It takes 5 and it takes all the spectral signature and then divide them into these 5 classes and then present them as a specific color. So the green is all the spectral signatures within that class. Okay, anyway, let's zoom out again a little bit. Okay, there they are. Let's make it a bit bigger. Then now that's what I'm gonna go and identify. Okay, so let's now the trick or the main focus for the researcher would now be to identify the color schemes and to harmonize or to align these color schemes between the various classification methods. So let's take the inspector. Let's go into a specific area. And let's, for example, say a river. There we go. Let's click on that river. And let's see which class each of these classifications they represent. So in the KMeans for LandSat 5, they are cluster 3, green. In the XMeans, remember XMeans use color palette 2, they are 4, which is purple, you see. So 3, green, and purple. So, yeah. And then for LVQ, they're green, after 0, which is gray. For 7, it's the same, 3, but you can see in 7, X is cluster 3, not cluster 4. And the LVQ is cluster 1 and not cluster 0. So you can see there's differences. It simply could be that the land use have changed, so it's not necessarily wrong. It means that, let's say here in LVQ, in LandSat 5, the LVQ, it was, remember that's for the median image in that period. It was classified as 0, but for the LandSat 7 period, it was classified as a 1. You see that in cluster 8, the KMeans in LandSat 8, it's 3, LandSat 7 it's 3, and LandSat 5 it's 3. Let's have a look at LandSat 9, KMeans is 1. So you can see it has changed between the different LandSats and the different classification methods. But it does seem fairly consistent up to LandSat 8 and with the KMeans that it is classified as 3, see 3, which is green. Okay, you see it's going to take forever to load because so many of them. Okay, so you can select, you can press on the inspector and you can select your training area or your specific location that you're interested in. And the inspector will say within each of those unsupervised or clustered classification methods, which class it has allocated to that specific feature. Okay, and that allocation of that feature is represented by a specific number and a specific color. It's now for you to understand when we use KMeans and LVQ, gray features, what do they present? Or what do they represent? What is the feature on a surface that they represent? Or purple, or green, or black, or orange. That's now where the science comes, or the effort comes into. Okay, let's close it a bit and see what happens. Okay, so there's all this, the unsupervised classification or cluster classification methods. We've applied it to each of the 4 LandSat data sets. The resulting images, classification images, are displayed. Remember, they are for the median images. And now, as I said, the trick is to identify or to allocate the features to the different class numbers and colors. And then you can be able to determine whether a specific class have increased or decreased in quantity over the period, and that specific or any specific region of interest or location, how did its classification change over time, etc., etc. Okay, so this is the unsupervised or clustered classification method applied in Google Earth Engine. Thank you. I hope you enjoyed this video tutorial. I hope you enjoyed it as much as I did. I look forward to having you on board this incredible journey in remote sensing. And with that, I'll see you on the other side.